Alright, in 11b we're asked to find any inflection points for this graph. So we have to figure out when the second derivative changes from positive to negative or negative to positive. I'm going to use this form of the first derivative to get our second derivative. So our second derivative of e to the negative x is going to be e to the negative x times negative 1. Right, doing the derivative of the exponent there, minus the derivative of this whole thing here. So when we do that derivative, we're going to need to use the product rule. So I'm going to put this in parentheses because we're subtracting that whole thing. And derivative of x is just going to be 1 times e to the negative x plus x times derivative of e to the negative x is e to the negative x times negative 1. So if we go ahead and simplify this a little bit, then we have negative e to the negative x. Distributing this, we get minus e to the negative x. This is a negative x e to the negative x, but we're subtracting it, so it becomes plus x times e to the negative x. So these two are like terms. We can combine those. We get negative 2e to the negative x plus x times e to the negative x. Well, we need to figure out when those two are 0, first of all. So we can factor an e to the negative x out. So we've already figured out from part A that e to the negative x cannot equal 0. It doesn't work. But x plus negative 2 can equal 0, and that happens when x is 2. So we want to make a number line for our second derivative. We know that when x is 2, second derivative is 0. We want to check on either side of that. So if we put 0 into this equation, we're going to e to the 0 would give us a positive value. Negative 2 plus 0 gives us a negative, so we know it's going to be negative here. And we want to try 3, e to the negative 3, that's 1 over e cubed, still positive. Negative 2 plus 3 is going to be positive. So this is positive. It changes here. So we have an inflection point at x equals 2.